Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. So for today's episode, I'm joined by Abdullah Jaber, who is the founder and CEO of a really interesting company called eTrailer Dynamics. Welcome to the show, Abdullah.
Hi, Ryan. Thank you for having us here.
Great. So if we could start by just getting to know you a little bit better, and if you could tell me some more about yourself and your background, where you came from.
Yeah, right. So actually, and this is the funny part, although we have a kind of, let's say, engineering technical startup that we have, or technology startup, I'm actually not an engineer. I'm a physicist. And the funny story is it begins actually a little bit late or very, very early, where I had a fight with my parents towards wanting to have a motorcycle license.
Okay.
And my mother was really in opposition of this idea, and we ended with a truck driving license. And when I started then and went through the physics studies, I found a diploma thesis. It just at that time in Germany they were not at this bachelor master concept yet.
Yeah.
They had this diploma, and it was in Cologne, and it was about truck efficiency. It was open for engineers and scientists, and I was the only one, obviously, with a truck driving license. And the topic was actually, how can we improve the efficiency of trucks, and how can we introduce new technologies like electrification, improved aerodynamics, so on and so forth. And the background was that there was already something like the Toyota Yaris and all these new hybrids coming up into the market, in the passenger car market.
Yeah.
But at the truck market, nothing was going on. And it was a collaboration between DLR, this is Deutsches Institut für Luft- und Raumfahrttechnik, and University of Graz and other Delft, I think. And the idea was to give recommendations to or let's say guide the European Commission how they can change or tweak a little bit some regulations to make it easier for the introduction of these new technologies. And the formula was quite simple. Give them permission to be a little bit heavier and a little bit longer to be able to introduce or implement this heavy battery electric drivetrains and improved aerodynamics. After that, I went back to Aachen and worked a long time on gravitational physics.
Okay.
And after that, I came a little bit into the industry. At some point you have to decide if you want, after studying physics, being a taxi driver, or doing something meaningful.
Teacher.
So yeah. So I went a little bit into I had a own small company, and I went to a major software company where I had already some friends there, and we worked just by accident on, let's say, this idea. You worked on that, and let's think about that. And we developed the digital twin and model for this new idea. I will come to that in this software company. And the funny part was, when we were actually at the level where everybody was convinced, this company said, yes, we are a software company. Your, let's say, idea or solution is very heavily weighted into hardware. So solve the hardware issues and come back.
Yeah.
This was like the initial spark to start or found this company. And in very short time, I just had some other and business angel, and then step by step, we had some strategic investors, and yes, now we are 7 years into this company. We have roughly 100 employees,
Yeah.
and we have changed a lot in the market of transport and logistics. Yes.
Wow. So just going to go back a little bit because it's you've got my interest around the truck driving license part. So I'm just wondering, I mean, that's quite an unusual combination for someone to study physics and also want to, or well, maybe not want to, be pushed by their mother into doing a truck driving license, truck driving licenses are incredibly hard. You've got to have good sort of spatial awareness and things like that. How did it feel doing that at a similar time to being a physician?
Yeah,
no, physician's the wrong word. That's a doctor.
yeah,
Physics.
Yeah, physics, right? So uh, um, th- actually, if we think about it, this journey started way earlier. At some point, my parents were in South Sudan, working there in I don't know how we call it in English. It is these people who are trying to help other people to improve their life standards.
Okay.
Entwicklungshelfer, we call them in German.
Like an aid worker, maybe, or something?
Yeah, something like that. Absolutely.
Yeah.
And there are no rules, no police, nothing. And I started actually driving. My first driving experiences with tractors and trucks was with 11 years.
Okay, yeah.
So I had some skills, and that happened to be also that at least in doing that driving license here in Germany, it was like cake eating, yeah, right? Very, very fast, very smooth. I had an uncle who was a pilot, and so on and so forth. So I think there was a kind of natural force pushing us towards doing such crazy things. But the impressive thing is that if you start studying physics, the first 1-2 years you are dealing a lot with mechanics, dynamics, something like driving resistances, control algorithms, something like that. And if you have, let's say, a physical connection to the real world, experiencing with this kind of things with your own body, this makes it way easier to, let's say, dig into or understand the deep background about what is happening, right? If you're driving with your bicycle a mountain hill, or accelerating, or driving against, let's say, the wind, I think it is very easy to understand what kind of forces are acting on you.
Yeah.
And that is really, I think, a benefit.
It's a little bit different. The classic sort of stereotype of the physics student being very intelligent, but they maybe are not so aware of the practical world around them.
This is also true. Yeah, and this is really something where I was in my, if I remember, in my young years, really pushing the people to do a little bit more practical work, experimenting, going for courses, because at some point there is a disconnect between what we are. So some people are confusing physics with math, and going through the strangest theories, and in the end, this is really not leading to any practical solution. And in physics, we have these branches of theoretical physicists, experimental physicists. There are some people who are really, if you think about, let's say, CERN or others, somebody needs to build these machines, right?
Yeah.
So there is always a kind of natural connection between the scientist or the scientific branch and the engineering branch, because somebody needs to, let's say, translate. And this is not a one-directional communication. So it is like you have this bi-directional communication. And that was actually also in my career, my main role. Yeah, kind of trying to translate what the let's say, high level, super artificial theoretical physicist is thinking about, and trying to understand what kind of experimental setting you have to design and engineer to give him, let's say, the instruments he needs to do a proof. Yeah.
Interesting. And luckily, your mother convinced you not to do a motorcycle.
Yeah. This was a wise decision. I had so many accidents. Yeah.
Yeah. So then, so it's a really interesting backstory in terms of your career through science and then getting more involved in the practical sort of engineering side of it. I'm an engineer by background, so I kind of understand the engineering journey. There's always a little bit of tension with between the engineering camp and the science camp. But so you set up the business. Was it 7 years ago?
7 years, yeah. It was in January 2018.
Yeah. And what was the kind of founding vision for the company at that point?
Oh yeah, so let's build the bridge. My father is also an engineer, and he was in the petrochemistry, working for several years in Kuwait, and he was, although he was working on this industry, he was like embracing and trying to push efficiency, kind of, and also trying to do everything he can to find everything he can to find solutions to improve, let's say, the impact on the environment. So both of these impacts were also driving me towards thinking about how we can improve transportation, for example, right? And when I was in this software company, we already had some very interesting solutions just by side, working on that, improving aerodynamics of trucks. But at some point, we came also back towards the electrification, and what we saw was that electrification will be a thing, because there was already very obvious that there were regulations put on the agenda to improve efficiency of trucks, but also a phase out of diesel.
Yeah.
But what we also know or knew at that time is that, yes, batteries will become cheaper and better, but they will still be heavy and bulky.
Yeah.
And the problem that we saw is that the let's say, the packaging volume that is available on, let's say, European standard tractors is too small to accommodate the energy that is necessary, even under super optimistic conditions, to cover, let's say, the distances in long haul applications that normally are driven by diesel trucks, something like 700, 800 kilometers per day.
Yeah.
And we saw that trailer, and at that company, at the software company, we had a project with Bosch where we were working a lot on trailers, but more on the software side from the ERP point of view, because the trailers themselves were just dumb boxes on axles.
Yeah.
But the nice thing was that the trailers themselves were the main contributor for the driving resistances, obviously, because they're good transporters, and they had a lot of available space for a drivetrain or a battery. But let's go for the battery. So the first obvious idea would be, let's use this space to extend the battery capacity of the whole vehicle combination.
Yeah.
But the problem that you will obviously see, and this is at some point also going to transcend in our cooperation together, is that trailers and tractors are interchangeable, or should be interchangeable. And if that is true, you cannot, let's say, put the controlling or the energy connection and marry these vehicles together. So you need to be super flexible. So energy transition is not a thing. It is dangerous, and there are a lot of technical, let's say, obstacles or hurdles to make that. So the next idea would be, can we put a real drivetrain, and a propulsion into the trailer? And the next thing is how can we control it? Because there are a lot of trucks, and while these trucks were developed, nobody thought about and let's say we call it now officially eTrailer, an electric trailer with a propulsion system.
Yeah.
So the obvious idea was very similar to an e-bike. Can we use the coupling or the, let's say, coupling interface to measure the dynamics of the truck and give the trailer the ability to dynamically react in the proper way to the dynamics of the truck. So in the end, we had also to solve this let's say problem to make the trailer as easy to, let's say, integrate into already existing truck fleets as possible, and therefore we had this censored kingpin solution. Yeah.
Okay. So it's really a matter of trying to kind of keep the separation between the truck and the trailer, but give the trailer enough awareness of what's happening without relying on anything too specific on the truck.
And it is very similar to the concept of the e-bike. The e-bike itself has no physical, let's say, data connection to the driver, but there is some control input by the crank on the hand and obviously the brakes. And the e-trailer needs to predict or understand what the driver is actually wanting to do. Yeah. Sometimes that you're standing, if you have an experience with an e-bike, you're standing at the red light, pushing a little bit into the crank, and the e-bike normally, if it's good designed, is doing nothing. It's kind of knowing that you're ready to start. So you have a lot of let's say interactions with your environment, temperature, vibrations, whatever. And this is super complicated. Also with the eTrailer, you have a hysteresis and other things. And this is where then you come from, let's say, this physics background where you have to deal with in this very sensitive experiments with all the noise, we call it Rauschen in German, with and trying to find the right setting for a sensor setup that helps you to actually do the job. Yeah.
Okay. And the eTrailer as a concept, because anyone, I mean, trucks are a little bit different in the US to Europe and the rest of the world. But fundamentally, that kind of architecture of a tractor unit and a trailer is a common one, with a kingpin and a fifth wheel connection between the two. Trailers have come along some ways. Like the dumb box is still. There's some more smarts in the trailer now in terms of things like anti-lock braking and stability control.
Right.
So in your work that you've been doing, because if you just had a purely electric tractor unit sitting on the front and a normal trailer on the back, actually in that scenario, you'd be wasting energy, I guess, with a normal trailer with its brakes trying to slow the truck down. So how much interaction does your electric system have with the actual sort of control of the trailer and stopping it from was it jackknifing, overtaking?
Right. So it's just a super complicated thing, and there's a nice saying. You remember when Kennedy was introducing the Maughan program, he said something like, "We are not doing that because it's easy, but because it's hard." We actually didn't know that it is hard, but now we are anyway on the way.
Yeah.
And we had to solve a lot of technical problems, but we had also to understand actually what our customers were looking for. So we have this possible applications. You can couple this eTrailer for some applications with a battery electric truck, and I will come back to that, but also with a diesel truck. I would suggest let's start with a diesel truck, and this
Okay.
is the first, let's say, no-brainer. If you want to comply with these emission reduction targets or efficiency goals, having per definition, we know that there are CO2 emissions connected with the use of battery electric vehicles. Obviously, depends very much where you're getting your electricity, and also the impact of building these vehicles is something that we need to talk about at some point.
Yeah.
But in the scheme of the regulations, you will have a trailer that is making itself as light as possible. Let's say that way, without any pipe emissions.
Yep.
And this is having an immediate impact in really reducing the fuel consumption and the CO2 emissions of the trucks. And this is the main application right now, because we have a lot of, I think, 2 million semi and normal trucks on the roads in Europe today. And we have customers who have these Scope 3 emission targets where they have to reduce their own impact in their operations immediately.
Yeah.
So this is where the eTrailer helps a lot. On the other hand, let's say braking and recuperation is not an easy task, because you have a technical part, but you have also regulatory part. So
Right.
the truck is always in charge of braking, and the truck needs to have control over the brakes. And if you have a battery electric secondary drivetrain,
Yeah.
the drivetrain itself needs to know, or let's say, if you want to do proper recuperation reliably, you need to know a lot of information. What is the condition of the battery, state of charge, temperature, how much energy can it accept or power. So, and on the other hand, as the regulatory R13 for braking was made, nobody was anticipating this eTrailer topic, and there are some let's say, requirements that are counterproductive to what an efficient recuperation system needs to do. So you have you have to brake evenly on 3 axles and so on and so forth. But the interesting thing is that and this is something that we have to actually highlight, is the eTrailer is not a solution to replace conventional trailers, but it is a solution to improve long-haul applications with trailers.
Okay.
And the funny part is, if you're going a lot of on long distances on autobahns, you're not really braking a lot.
Okay.
So what we have seen is, in average, if you want to use every possible situation to do recuperation, in average you will be at 3 to 5, 6% in energy that you could actually recover.
Okay.
So if we go now towards the future, and this is the other point that I wanted actually to emphasize, let's say we have battery electric tractors in front with a limited range, and you have a trailer that can cover part of the driving resistances. And in this situation, 40% in the front, 60% in the back, you can double the range at least, right? But the tractor will be always the bottleneck in this equation. Yeah. And if you can or if it is, no, it makes a lot of sense to give the tractor every opportunity to do the recuperation itself.
Right. Okay.
So you have a kind of in average an energy transfer also from the back to the front. Not directly, so the trailer is not allowed to push, but it is giving the tractor the possibility to let's say, improve its SOC.
Okay. There's an awful lot of sort of subtlety in the control.
Yes. And you have, as it is the secondary drivetrain, it is very depending on the conditions and the state of the tractor. So like an e-bike, we are, let's say, supporting after passing a kind of threshold, like 5 kilometers per hour, something like that, because there it makes sense. We have a very sophisticated safety functional safety program to make sure that the trailer doesn't do any dumb things. And the trailer is like everything that is kind of unclear, it goes, okay, I'm out of the equation. Do whatever you need. And even in braking situations. But coming back to the recuperation thing, so we have to have a trailer braking system that can incorporate the recuperation capabilities of the axle into its braking program and decide if you are going 100% with recuperation or blending it in with the friction brakes or going only for friction brakes because the battery is not available, something like that. We are working on introducing new messages in the standard communication between truck and trailer to introduce functionalities of the trailer to the new tractors. Yep. This is something where we expect that 2026 we will have that, working with all our competitors and industry partners on that to have a kind of standardized thing. It is, and I myself, when I started this idea, I hope that I can convince somebody with this concept and they take over. But in the end, everybody was like, "You have to do that yourself." And this is where we are today.
I guess the saying of the ideas are easy; it's the execution.
Ideas are easy. Implementing or making these ideas work is the hard but funny part as well. Yeah.
So, in terms of then practical implementation and the execution part of the business, how how far down that line have you got? I guess the opposite of that question being how close to commercial sort of rollout of the technology do you feel like you are now?
Right. So I think for our listeners, this is also important to know or interesting that you don't have only the technical, let's say, problems or obstacles, issues that you need to solve, but you have also the regulatory, you have also to talk to your customers, something that we had to do, and you have to, let's say, converge with all this multi-dimensional task towards, let's say, an SOP, right? This is where we want to go. So what we had to understand is actually what is the requirements or what is the market, the customers asking for. And in the beginning, we started with, let's say, the first run, we started with a battery capacity of 120 kilowatt hours and said, you know what, this is what we expect our customers to need to get to this, let's say, 15% emission reduction targets. But in the end, we learned together with our customers that the opposite is actually what we need to do, bring the efficiency as high as possible. And the reason for that is that diesel is, from the efficiency perspective, the worst thing to use. And we need to come to a solution where we have to have this positive impact from the battery electric drivetrain. And we had also to convince the EU legislation to come to a regulatory framework for these e-trailers where they make economically sense, but also from the environmental perspective. And so we are now on the second, let's say, timeline where we had to convince ourselves, our customers, and the regulatory bodies that a specific battery size and axle power output is really something that needs to be set up to meet the expectations.
Okay.
And make everybody happy. And therefore, this is the software part where we were lucky enough to have this MATLAB Simulink digital twin where we went through digital, let's say, landscapes and went through the overall dynamic models to have a kind of idea where we have to be, what kind of power output we need from the axle, what kind of battery capacity. And luckily we were also in practice right with our simulations, very close to the reality. And on the other hand, by seeing that the EU came with new rules that trailers need to contribute also in improving efficiency or reducing CO2 emissions. And there were then goals set for all trailer manufacturers, so making the market ready for our solution.
Yeah.
The eTrailer was introduced in a homologation and directive. And on the other hand, we had also the recognition of the eTrailer as a compensation tool for diesel trucks. So I think this is the necessary, let's say, setup for introducing this technology on the one hand. But on the other hand, we had also to work and obviously also comply with regulatory or with regulations like the R100 that didn't include battery electric trailers. And we had to understand together with the industry what the requirements are and then design the vehicle to comply with this regulatory. The same was also with the R13 to understand at what point we can recuperate, so on and so forth. So a lot of, let's say, multi-dimensional orchestration is working. And to answer your question fast, since middle of last year, we were able to register these vehicles or do the registration under German law for single type approval.
Okay.
And we are working very hard to come with the industry towards an homologation.
Okay.
The R13 is not ready yet, and we're working together with our stakeholders to get there. But it is like this month or at the end of this month, we will have a design freeze that is ready for sale.
Okay.
So we can sell these vehicles, and we have, I think, until now some 7,800 something, or I don't know the number because it is too big for us. Yeah, in pre-reservations, a lot of reservations. So this year, if everything goes well, we hope to sell 50 vehicles.
Okay.
The year after 250, the year after, and this is where we will get into the SOP. Hopefully 2,500. And coming back to this regulatory towards efficiency of trailers, we believe that we need to address 10 to 30% of the market with e-trailers to avoid any, let's say, fines from the EU for the trailer manufacturers. And these are really big numbers. And we need to use this time from the SOP to get the industrialization of these vehicles right, to make them available and affordable. This is also a very important part.
Yeah.
And we shifted our business model from, so Krone, one of the biggest trailer manufacturers in Europe, is one of our shareholders. And at the beginning, we thought, you know what, we should have this kind of interaction and let's say close connection between Trail Dynamics and Krone to bring these vehicles onto the market. But we saw that our actual market is not selling trailers, but empowering or helping all the trailer manufacturers to be able to introduce these e-trailers. So our new business model since 2 years is we want to offer the whole drivetrain with all the control softwares, sensor kingpin, what you name it, to every trailer manufacturer who's willing to bring an e-trailer onto the market.
Okay. So you'd be like a tier one supplier.
Something like that.
Yeah, interesting. Because obviously it is a common model in that trailers already are a kind of assembly of components from key suppliers.
So we don't want to disturb the market, but we want to improve or be the enablers. It is like, this Apple, Google approach.
Okay.
Every Android is working on several phones.
Yeah.
And or you have this closed environment. To be honest, you have all the available industrialization and production capacities already available at the trailers. At the trailer companies, they have their own customers, market, trust from their customers, and we don't want to disturb that or come in as let's say the 10th or 100th trailer manufacturer.
Yeah.
We think that we need to focus on what we can do the best, and this is having also a lot of implications on our let's say engineering and design. So we are now focusing very much on making standardized battery compartments, standardized axles, standardized, or we are putting our sensor technology on already standardized kingpins.
Yeah.
Working very openly and fairly with all trailer manufacturers who are willing to get this technology, and this is what we're doing.
So do you feel now like there's a strong pull? I mean, obviously there's a lot of change happening in the market, and you talked about the regulatory change and all this, but does it feel now, because from what you've said, the last few years you've had to really push to make things happen. Does it feel now like the market's starting to pull?
Yes, absolutely. So there are already some competition coming up, and this is a good thing because this is a kind of proof that what we're doing is actually a good thing, right?
Yeah.
But we need to stay ahead and use our first mover, let's say, impulse and stay ahead of this competition. So we have to innovate, offer the best product, hopefully for the cheapest price.
Yeah.
But the impression of the industry was in the beginning very interesting. So in the beginning, everybody thought, we are crazy, not relevant. We will find other solutions, from hydrogen to, the batteries will improve a lot.
Yeah.
At some point, when people saw, with this small number with this small team, they have a working vehicle in quite fast time. Oh, interesting. We need to talk. And then came a situation where there was like there is trailer dynamics, but it is not made here, and we need to get our own solution. But now we are recognized as, let's say, the solution providers for this kind of technology, and we are somewhere partnering with a lot of our suppliers to get the numbers right, also from the financial perspective and from the performance, make our supply chain stable, the product good and stable as well. I think we are coming to stay.
Mm-hmm. Yeah. Oh, good. So the actual system itself, you mentioned at the beginning quite a large battery, and then you sort of said that you've done lots of analysis and it had changed. Where did you end up going? I'm guessing from what you said, you had a smaller battery now than in the beginning. Like, what kind of size battery does the system have now? How much is that?
Right. So you can crunch the numbers actually very easily in your head. So a battery electric truck, as reference with a conventional trailer, needs roughly 1.2 kilowatt hours per kilometer. These vehicles need to drive per shift maximum 700, 800 kilometers. And if you do the multiplication, you come very close to 1,000 kilowatt hours. But in reality, a little bit less is also sufficient for most applications. So the battery electric trucks nowadays, the good ones, have 500 kilowatt hours available.
Yeah.
And our eTrailer has 550 something. and kilowatt hours available. So together, they are now capable to do this long haul applications with no intermediate charging. And the intermediate charging is actually something that is annoying for several reasons. The first is, if you take these big battery capacities, for example, just let's take the truck and let's assume that it can do half of this route. At some point, you have this chargers that are nowadays capable to do 300, 400 kilowatts.
Yeah.
And you can then imagine that you will need at least 1.5 to 2 hours, if you're lucky and nobody's sharing this charger with you, for the recharge. You have to stay there for long. You have to block these chargers. And the chargers themselves, because they are providing this energy on demand, are super expensive compared to depot charging.
Yeah.
So it is really a big pain that is happening there. This is where the eTrailer is having its highest impact. In Nordic states, sometimes these tractors need to pull up to 90 tons, so 2 trailers in combination. And then the range of the battery electric truck for itself is super small. Yeah, it is roughly a little bit more shy than 100 kilometers. And this is not really feasible. So if you have a combination of 2 e-trailers with a battery electric truck, you're back in the game.
Yeah.
So it's an enabler, but it's also improving the total cost of ownership. And if we think about a future where we will not have any diesel trucks anymore, this charging infrastructure issue will become a real issue, a big issue, because you need a lot of energy, a lot of space, and cost effectiveness is a point. The drivers need to come from A to B without wasting a lot of time at the chargers.
Yeah. I hadn't really thought about that, but actually you make a very good point. So even if you considered, so the new big truck chargers are sort of megawatt charging standard, for huge things. We all know very big, require a lot of power. Getting power onto site is going to be difficult in a typical remote location for a truck stop and things like that. So there's a lot of infrastructure challenges there anyway. But actually, at a really simple level, the comment you made about the cost difference. So anyone with an electric car knows that you want to charge at home. Right. If at all possible, you want to charge at home because it's normally at least a fifth, of the cost. So 20%. So the cost of charging in the wild is 5x the cost of charging at home, or more. So if you can charge at home, actually, or you can charge much more sort of flexibly around using off-peak power as well, rather than having to take power at expensive times and things. There's a big operating cost differential just in that.
And for us as private car users, passenger cars, it's not always hurting. But the truck industry, they are really in a very competitive environment. They have to compete against diesel, against everything that every cent you use you can save is like a win already for you, right?
And they already do it with diesel trucks, don't they? That the operators have that do the long distances have big fuel tanks and they refuel in the cheapest place.
Yeah, right. And if you go like on highways on these filling stations, you will never see a truck filling up at these stations because it's super expensive. That doesn't make sense for him.
Yeah,
right.
Yeah. So they fit the extra fuel tanks and go to where they can buy the fuel for the least price. Yeah, so it's the same.
Right, and let's stop here to have really a sense of about the difference between today's diesel trucks in these long haul applications and the battery electric trucks. So one of our Volvo electric trucks, they have a big battery. It's a super nice vehicle, but the diesel truck with the big diesel tanks can go roughly 2,000-ish kilometers on one tank level. and the battery electric 220, 250. So it's roughly a tenth of what the diesel can make. This is really, so it requires two or three things: that the operators need to change their operations and adapt to the needs. And we are quite far from getting at somewhere near what is actually nowadays available by the diesel trucks.
Yeah.
So at least being able to cover one shift is helping a lot. A lot of these trucks are driving in 1 day shift businesses where they are going to their customers and coming back. Some of them who are driving for long distances, let's say from Birmingham to Portugal, this is also something that is happening. At that point, the drivers will have to rest at some time, and we think recharging while sleeping is something that is feasible. But we need to make the range of these vehicles, let's say, acceptable.
Yeah, it's an interesting area, and that, I mean, anyone who's been anywhere near a truck stop point, you know, they're already congested, and there's not enough space for drivers to park and things. So,
but we have also another. So by accident, we discovered two things that are very funny. I didn't think about that. The first is that now the battery electric truck and the trailer can simultaneously charge. So if you are going, and this was a surprise because we had a tour, the first tour that we had to Spain, we thought about, wow, we need to plan this and this charging time, so on and so on. And we forgot that we can do this simultaneous charging. So we had a diesel truck as a fallback driving with us. And we were 2 to 4 hours faster at our destination compared to the diesel truck, because we just needed 2 intermediate chargings, and each of them just cost us 2 hours.
Right.
So this was a surprise. The second was that we were an average faster because we have, compared to the diesel truck, roughly 800 horsepower more in the trailer.
Yeah.
So we're an average when we were driving climbs or doing acceleration faster, and therefore we were per shift kind of half an hour or more faster at our destination. And we have seen that this is something that the truck drivers who are using now the eTrailers are really appreciating much. The only bad thing is when they are driving in average faster, accelerating more because they have the power, the overall energy consumption is also higher. So we have to calm them down and say, you know what, I know you are now kind of driving a Porsche, but please be as easy as possible to save energy. But at some points, we saw that some of the companies who are using the eTrailer, for example, in company logistics, they are actually emphasizing to drive faster because they can then do more in that time, right? Transport more.
Yeah.
So very interesting new insights into this application.
Yeah, the trade-off of speed and efficiency, and the efficiency of the asset itself in terms of being able to utilize it.
Right.
Yeah, fascinating. So, just mindful of the time here, we could probably continue talking for the rest of the day, but I know you have to get back to doing what you're doing at Trailer Dynamics. So, looking forwards into the future, what are you most excited about that's going to happen for you over the next year or so?
So I think these systems will improve also the efficiency a little bit. So we think that we will get to some 10% more efficient trailers compared to today. But we see also a shift in the battery technology that is also true for trucks and probably passenger cars, where we have this shift from lithium to how we call it in English, and in German it's natrium. It is the second element after lithium. What I'm trying to say is that batteries will drop down in cost up probably to the half of what we know today.
Yep.
And this is something that wasn't really obvious in the last decade, that battery electric trucks and trailers and passenger cars will be in the overall production costs and operating costs cheaper, way cheaper than petrol or diesel trucks.
Yeah.
So this is something that is really encouraging to see that we have a realistic opportunity and chance to decarbonize transportation. Not everything, so airplanes, ships, and other things are also a challenge,
Yeah.
but at least on the road. And the very charming part of that is that it is not really like a lot of people were afraid of electrification as a job killer for innovation and production and vehicle manufacturers, but we see that they are also producing obviously new jobs. That is, everybody who's working at Trailer Dynamics is working on the future, and that we are capable in Europe to do these innovations is also a very important part that we need to underline here. If we are going to a situation where we have a partial or full automatization of goods transport also on the road, autonomous driving or something like that, electric trailers and trucks are way easier to adapt to these new technologies because they are less complicated. They are generating a lot of important data. It could be also that we will have still a pulling segment, let's call it that, probably without a cabin. Something like that would be very interesting. And as the trailers are the main good transporter, we will have the trailers themselves will have a more important impact on that transition. So I think we have a lot of work to do in front of us, exciting times, and we will see a lot of changes happening.
Great. Okay. Well, thank you very much for taking that time out today to talk to me. It's been really interesting. It's fascinating. It's a whole other leg to the electrification side of things. I think most people very focused on the tractor unit and on cars without really thinking about the trailer. So great to see what you guys are doing, and understandably can see why you're excited about that. Huge opportunity. So yeah, thank you very much for taking the time out to join me today.
Thank you, Ryan, for having us.